Hello everyone, a very good evening to all. I welcome you all again for this interaction session on atomic and molecular physics. So this is our 11th interaction session. In this interaction session, we will be solving a few problems which will be based on the week 11 lectures of atomic and molecular physics course, which is being flowed this semester, this January 2024 session by NPTEL with course code NOC24 PH04. Myself, Vivekananda Naik. I am a research scholar in the Department of Energy Science and Engineering, IIT Delhi. So let's start with the first problem in the day. The question says the force constant of the bond in carbon monoxide molecule is 1850 Newton per meter. Find the energy of the lowest vibrational level. The reduced mass of carbon monoxide molecule is 1.14 into 10 to the minus 26 kg, and the value of Planck's constant is also given, which is 6.626 into 10 to the minus 34 joule into second, and Avogadro's number Na equals to 6.023 into 10 to the 23 per mole. So the options are option A 0.132 electron volt, option B 0.234 electron volt, option C 0.343 electron volt, and option D 0.434 electron volt. So this is the first question. Now, if you see the question, it says the force constant of the bond in carbon monoxide molecule is given. So the force constant, which is we denote generally it as K. This K is given as 1850 newtons per meter, and again the value of Planck's constant is given H is equals to 6.626 into 10 to the power minus 34 joule into second, and then Avogadro's number is also given because we will be needing the Avogadro's number, because if you see the uh, question, you will be needing the Avogadro number in the calculation. So Avogadro's number is also given, 6.02 10 to the power 23 number of atoms per mole. And again, the reduced mass of carbon monoxide is again given. Reduced mass, which is nothing but reduced mass U of carbon monoxide is equals to 1.14 into 10 to the power minus 26 kg. Now, what we need to calculate? We need to calculate the energy, find the energy of the lowest vibrational level. So, what is the energy of lowest vibrational level? So, now notice the energy of the vibration level is given F, so we need to calculate, and the energy which will be calculated, we need, in the options are given in terms of electron volt, so we will convert the energy which will definitely coming in terms of joule, because all the values of the quantities given are in terms of joule, so or in terms of standard system of units. So you need to convert the final answer into electron volt again at the end. So I'll give a few minutes to you to try this question, then I will solve it. So let's solve this question. Now we need to find out the energy of the lowest vibration level. Now we know the energy of a vibration level having vibrational quantum number V is given by the energy given by EV equals to V plus half h plus omega. Now, in order to find out the energy of the lowest vibration level, we will take the value of the lowest value of V also. Obviously, we will take the lowest value of V. So the value of V varies from 0, 1, 2, 3 up to higher value. So for lowest vibrational level, for the lowest vibrational level, V will be 0. So E0 will be 0 plus half h plus omega, which is nothing but h plus omega by 2. Now we know the value of h plus because h plus is nothing but h by 2 pi, and the h value is also given in the question. Now we need to find out the value of omega. Now, if you remember the value of omega, there is a relation between omega, force constant, and the reduced mass, and that value is the relation is given by omega is equals to k by mu square root. So first we will calculate the value of omega, and then we will put the value of omega here in order to find the value of the lowest vibrational level. Now omega is given by k by mu root over, again the value of k is given, which is 1850 Newton per meter, and the uh, reduced mass of the carbon monoxide molecule is given, which is 1, 1.14 into 10 to the power minus 26 kg. 1.14 into 10 to the power minus 26 kg square root. So if you solve it, you will get the value of omega is 4 into 10 to the power 14, and it will be definitely second inverse. So this is the value of omega. Now, so E0 will be how much? H plus omega by 2, that is H omega divided by 4 pi. H is 6.626 into 10 to the power minus 34 into the value of omega we just calculated. It is 4 into 10 to the power 14 divided by 4 into 3.142. So the value of the energy will be, if you calculate, it will be 2 into, since all the quantities are in SI units, so the value of the energy is coming out in terms of joule. So the value is 2.11 into 10 to the power minus 20 joule. Now, in order to convert it to electron volt, we need to divide it by 1.6 10 to the minus 19. So if you divide it, it will be 2.11 into 10 to the power minus 20 divided by 1.6 into 10 to the power minus 19 electron volt. So it will be 0.132 electron volt. So this is the answer. Now, if you see, the question was the force constant and the reduced mass of carbon monoxide molecule was given, and we had to find out the value of the lowest vibrational level. Now, the lowest vibrational level corresponds to V equals to 1, where the energy of the vibrational levels are given by the formula EV equals to V plus half x plus omega. So when you put the value of V equals to 0 in the place of V, then the lowest energy state, which comes out to be h plus omega by 2, which is the ground state energy, because we know that the ground state energy is always the lowest energy. lowest possible energy of a system. So now the value of h cross we know, since the value of h is given and h cross is h by 2 pi. Now for omega, we need to find out the value of omega and the relationship between the spring constant or the force constant and reduced mass, and omega is given by omega equals to k by mu root over. Then if you put the values and calculate, then omega is calculated to be 4 into 10 to the power 14 second inverse. So if you put the values, the value of energy, the ground state energy or the lowest energy level will be 0.132 electron volt. So the correct option is option A. Okay, so let's go to the second question. The question says, consider the force constant of the bond in carbon monoxide molecule is 1850 Newton per meter. Calculate the spacing between its two successive vibrational energy levels in electron volt. Given reduced mass of carbon monoxide is 1.14 and the value of Planck's constant is again 6.16 10 to the minus 34 joule per second. The options are 0.164 electron volt, 0.264, 0.374 or 0.424 electron volt. So I'll give you a few minutes to try this question, then I will discuss. So now if we see, this question is pretty much similar to the previous question, but the difference in the previous question we are asked about to calculate the value of the lowest energy level, but here we need to find out the spacing between two successive vibration energy levels. So as I had already mentioned, the energies of vibration energy levels are given by V plus half h plus omega. So the value of V varies from 0 to 1 to 3 up to higher values. So for V equals to 0, we have E0 equals to half h plus omega. V equals to 1, E1 equals to 1 plus half, that is 3 by 2 h plus omega. And for V equals to 2, E2 equals to 5 by 2 h plus omega, like this. So the labels are arranged like this only, and all the labels have equal spacing, because if you see delta E0 minus E1 or E1 minus E0 is equal to E1 minus E2, and again it is equal to E2 minus E3, because it is only increasing with a value of h plus omega. 1/2 h plus omega, then 3 by 2, 5 by 2, 3 by 2, like that only. So this is h plus half h plus omega, or h plus omega by 2, 3 by 2 h plus omega, 5 by 2 h plus omega, like this. So the difference in energy of any two levels, whether it is first two level or last two levels, consecutive levels, the energy difference will be nothing but h plus omega. So like in previous question, if you remember, all the values are also same. So in previous question, the value of h plus omega, or h plus omega by 2 was 0.132 electron volt. So it will be 2 into 0.132 electron volt. From previous question, h plus omega by 2 was 0.132 electron volt, and the data are same. So it will be 0.264 electron volt. So this is the value of the spacing between its two successive vibrational levels. So the correct option will be here, option B. So also, if you see, since now we're talking about the vibrational energy levels, so now let's discuss more about these vibrational levels. So basically, the vibrational level is nothing but the potential energy that uh, comes due to the vibrational motion of the molecule. So generally, if the particle of the system is vibrating from its mean position, suppose the mean position is x0, then we can expand it in terms of Taylor series. So the vibrational potential energy, which is a function of x, can be expanded as Vx0 plus x minus x0 divided by 1 factorial del V by del x at x equal to x0 plus x minus x0 square divided by 2 factorial del square V by del x square at x equal to x0, like that. So this is Taylor series expansion. Now, so at equilibrium or the reference point, then del V by del x is 0. So since we know force is given by minus del V by del x, and at equilibrium, whenever the system is at equilibrium, then the total force acted upon it is 0. So the value of del V by del x is 0 only. So if you put all these values, you will get. Now if the x0 is the reference point, then it will again be 0. If reference point, then Vx will be 0 plus 0 plus 1 by 2 x minus x0 square del square v by del x square at x equal to x0. Now this del square v by del x square is nothing but the force constant k. So in general, the value of the potential energy is given by Vx equals to half k x minus x0 square. And from so all the calculations we did, the value of k is this. So if you put this, since all these things are based on quantum mechanics, so if you put this value of potential energy to Schrodinger's equation, then after solving, the energy or the energy agent values will be coming out to be this EV equals to V plus half h cross omega, where V is the vibration quantum numbers, and corresponding to these, we have different levels and the energy spacings. I hope this is clear to you. Then, if you again, so now since you see all these levels are equispaced, so either the transition occurring from this to this level, or this to this level, or this to this level, then all the energy difference are same. So we will observe only a single spectral line. So a single spectral line will be observed because the spectral line corresponds to only the value of energy or the energy difference between the two levels when the electron undergo transition or the atom undergo transition from one vibration level to another vibration level. So only one vibration spectra is observed since the vibration energy levels of harmonic oscillators are equally spaced. So one single spectra or spectrum we can say. So now the next question, the question says the force constant of a vibrating HCl molecule is 475 Newton per meter. Find the energy difference between the lowest and the fast vibration level of HCl molecule given H equals to 6.63 into minus 34 and Na is 6.023 new 10 to the power 23 per mole. The options are option A 0.135 electron volt, option B 0.253 electron volt, C 0.358 electron volt, and option D 0.463 electron volt. So this question is again bit more similar to the previous two questions we have already discussed. I'll give you a few minutes to try this question, then after some time I will discuss. Now let's solve this question. It is pretty much similar to the previous one. So again, but here the reference is only force constant is given, and we need to calculate the uh, reduced mass of HCl molecule. So since we want to calculate the energy difference between the lowest and the highest vibration level, and we know the energy difference is nothing but h cross omega, because the separation between the two levels is two consecutive levels is always h cross omega in term in case of vibration spectral vibration energy levels. So the delta is E1 minus E0. E1 is 3 by 2 h cross omega minus 1 by 2 h cross omega, which is h cross omega. Now h is known, omega we need to find out. Now omega, we know the relationship between omega k and mu is omega is equal to k by mu root over, where k is 475 Newton per meter given. Now we need to find out the reduced mass. Mu is the reduced mass of HCl molecule. Now for HCl molecule, it has hydrogen and chlorine. Hydrogen in terms of atomic mass unit, hydrogen is 1 mu and chlorine is, we take it as 35. So now the reduced mass will be so mu, we know m1 m2 divided by m1 plus m2. So it will be 1 into 35 divided by 1 plus 35. It will be 35 by 36. Then this is the mass of 1 mole of HCl molecule. So since 1 mole contains Avogadro's number of molecules, so we will divide this in order to calculate the reduced mass of 1 HCl molecule. That will be 6.023 into 10 to the power 23. Now, if you solve it, this 35 by 36, this is 1 gram and 35 grams. So in order to convert it to kg, we will multiply again 10 to the minus 3. So if you calculate this, it will come out to be 1.614 into 10 to the power minus 27 kg. So if we don't divide the reduced mass by 6.023 in 10 to the power 23, it will give the mass of 1 mole of HCl molecule, which will again contain Avogadro's number of molecules. So in order to get the mass of 1 molecule of HCl, we need to divide the reduced mass by Avogadro's number, which is 6.023 into 10 to the power 23. Now, the value of omega will be calculated. It is k by mu root over k, we know 475 divided by mu we just calculated 1.614 into 10 to the power minus 27 root over. So it will, if you calculate, it will come out to be 5.425 into 10 to the power 14 per second. Then delta E, that is the energy difference between the two consecutive levels. it is express omega. So it is 6.623 into 10 to the power minus 23 divided by 2 pi into 5.425 into 10 to the power 14. So if you calculate, it will come out to be 5.724 into 10 to the power minus 20 joule. It is 86.623 into 10 to the power minus 34. It is the head of Planck's constant. So if you convert it to again electron volt, it will be 5.724 into 10 to the power minus 20 divided by 1.6 into 10 to the power minus 19, which is equal to 0.358 electron volt. This is the answer. The correct option is option C, 0.358 electron volt. Now, the next question. The question says, find out the temperature at which HCl molecule excited from lowest vibrational level to the second vibrational level, given force constant of HCl molecule is 475 Newton per meter, reduced mass of HCl molecule is 1.6 into 10 to the power minus 27 kg, and the value of Boltzmann constant and Planck's constant are given. Now, if you see, in difference to the previous question, an additional constant value is given, which is Boltzmann constant, which is K equals to 1.38 into the minus 23. Why it is given? Because we need to find out the temperature at which HCl molecule is excited from lowest vibration level to second vibration level. So, in order to find out temperature, we need to convert the energy in terms of temperature, and we know the energy, if you convert it to temperature, the relationship between E and T is given by E equals to KT, or in terms of KT. So the energy we will calculate in terms of joule, we will equal it to the value of K into the temperature, and from that we can calculate the value of the temperature, which will be in the units of Kelvin. The options are option A 5323 Kelvin, option B 6424 Kelvin, 7525 Kelvin, and 8333 Kelvin. So I'll give you a few minutes to try this question. Then after some time we will discuss how we will approach with this question. So we know the real energy levels of vibrational level is given by V plus H plus omega. Now for the lowest vibrational level, lowest vibrational level V is 0, and for second vibrational level V is 2. So E0 is H cross omega by 2 and E2 is 2 plus half H cross omega, which is 5 by 2 H cross omega. Now delta E is E2 minus E0 is 5 by 2 H cross omega minus 1 by 2 H cross omega, and it is 2 H cross omega. This is the energy difference. Now, in order to find the value, we need to use the values given, and the value of spring constant is given. Spring constant is 475 Newton per meter, and the reduced mass is 1.6 into 10 to the power minus 27 kg. Then omega will be again k by mu root over, which will be 475 divided by 1.6 into 10 to the power minus 27 square root, which will be 5.45 into 10 to the power minus plus 14 second inverse. So the energy delta E is 2 H cross omega, which is H by pi, because 2H cross is 2H cross by 2 pi, so H by pi into omega 6.63 into 10 to the power minus 34 into 5.45 into 10 to the power 14 divided by 3.142, which is equal to 1.15 into 10 to the power minus 19 joule. Now, this energy is equal to the, now this E, if you convert it in terms of temperature, so it corresponds to per temperature, we can calculate it from the relation E equals to KT. So this E equals to KT is 1.15 into 10 to the power minus 19 joule. Now 1.38, the value of Kb, 1.38 into 10 to the power minus 23, the unit is joule per Kelvin, and it is joule into T is 1.15 into 10 to the power minus 19 joule. So joule gets cancelled out, and the temperature will be given in terms of Kelvin, which is 1.15 into 10 to the power minus 19 divided by 1.38 into 10 to the power minus 23 Kelvin. So if you calculate, it will give 8,333 Kelvin. So this is the temperature which corresponds to the difference in energy between the lowest vibrational level and second excited vibration level. For lowest vibration level, V is H cross omega by 2 because the value of V is 0. Then for second vibration level, the value of V is 2. So if you calculate, it is H cross omega by 2, and another is 5 by 2 h plus omega. So the difference in ground state level and second excited level is 2h plus omega. So this 2h plus omega, if you calculate, the value of omega is given by k by mu root over. So the value of omega is coming out to be 5.45 in 10 to the power 14 second inverse. Now this energy, now using this value of omega, we will calculate the energy. Energy is 2h plus omega, and the value of energy found out to be 1.15 10 to the minus 19 joule. And this energy, if you want to convert it in terms of temperature, the energy can be converted in terms of temperature as E equals to kT. So T will be E by K. Here, if you see the K is different here. So in order to distinguish the value of K, because here again it is K. So here we can write it as K subscript B. So and again this K is Kelvin. So there are multiple Ks here. So don't get confused with it. The temperature here T equal to 8,333, it is Kelvin, and this Kb is Boltzmann's constant, and the spring constant or the force constant is K. So if you put all the values of K and energy, you will find out that the temperature which corresponds to this particular value of energy difference is 8,333 Kelvin. So the correct option will be option D. Then go to the next question. In the near infrared spectrum of HCl molecule, it exhibits the vibrational wave number omega E 2865 centimeter inverse. Find out the force constant of the system. Given reduced mass of the HCl molecule is 1.62 into 10 to the minus 27 kg. The options are option A 472.4 Newton per meter, 572.4 Newton per meter, 672.4 Newton per meter, and 479 Newton per meter. So these are the four options. Now, how will approach this question? Now you see here, omega E bar is given and it is 2865 centimeter inverse. So this omega is different from the omega that we are discussing from the starting of the session. So this is in terms of frequency or angular frequency, but here this omega is different. It is vibrational wave number because the unit is centimeter inverse. So like in rotational spectra we are talking about, we are solving problems. There was a rotational constant which was B and its unit was again centimeter inverse. So this is different from the omega that we are talking about. So don't get confused with it. And we need to find out the force constant K. Force constant K we need to find out. So if you are thinking that here omega is given, K is given, so we know omega is equals to K by mu root over. So here mu will be K by omega square, or K will be mu omega square. So you will put the value of mu here, omega is given, mu is given, and you will get the value. So it is not correct because this omega is not this omega E. So omega and omega E are different quantities. So we will approach it differently. So now these are the four options. I'll give you a few minutes to try this question, and then after some time we will discuss. So how we will approach to this question? Now we know the relationship between frequency, velocity, and wavelength is frequency is equal to velocity by wavelength, or this one by wavelength is called as wave number, which is c nu bar. So this nu bar is nothing but omega I bar. So it is c omega I bar. So nu, which is the frequency, is 3 into 10 to the power 8 into 2865, which is equals to, again it will be multiplied by 10 to the power 2, because here the value is given in terms of centimeter inverse, so you will convert it into meter inverse. So you, when you are converting it from centimeter inverse to meter inverse, we will multiply it by 10 to the power 2. Then this value is given as 8.6 into 10 to the power 13 second inverse. Now we know the angular frequency, sorry, the angular frequency is given as omega is equals to 2 pi nu. So 2 pi into 8.6 into 10 to the power 13. Then omega equals to 5.4 into 10 to the power 14 second inverse. So this is frequency, this is the angular frequency. So now since omega is known, we will use this formula. K is omega square mu, that is 5.4 into 10 to the power 14 square, into mu is 1.62 into 10 to the power minus 27. So it will be 472.2, and its unit will be Newton per meter. So the correct option will be option A, 472.4 Newton per meter. I hope this is clear to you. Then the next question, the question says calculate the amplitude of vibration in the vibrational quantum level V equals to 0 of the carbon monoxide molecule. Force constant of carbon monoxide molecule is 1850 Newton per meter. The reduced mass and the Planck's constant is given. And here we need to find out the amplitude of vibration. The force constant is given. So how we will approach this question? The options are option A 0.048 Armstrong, option B 0.057 Armstrong, option C 0.069 Armstrong, and option D 0.072 Armstrong. So I will give you a few minutes to try this question, and then we will discuss. So now let's solve the question. Now here the question says calculate the amplitude of vibration. Now, if you remember, we talked about how the potential energy is expanded using Taylor series, and then we obtain this potential energy Vx is half k x minus x zero square. Sorry, this is so if if x zero equals to zero, then Vx is half kx square. Now this is nothing but the energy of the vibration and potential energy. So this value is equals to the energy that we will calculate. Now what is the energy? The energy, the vibrational quantum level V equals to 0 of CO molecule. Now V equals to 0 means E0 is 0 plus half h cross omega, which is h cross omega by 2. Now E is 1 by 2 h cross into k by mu root over. So if you calculate, again this energy is nothing but half kx square is half h cross k by mu root over. So x square will be, how much? This half gets cancelled out. It will be h by 2 pi mu into k root over, because root k and this k will cancel, and then this root k will be in the denominator. So if you put all the values, h is 6.63 into 10 to the power minus 34, 2 into 1, 3.142, and then mu and k. Mu is given 1.14 into 10 to the power minus 26, and k is 1850. So if you calculate, it will come out to be 2.298 into 10 to the power minus 23 meter square, since all the units are in SI units. Then x0 will be root over of 2.298 into 10 to the power minus 23, which will be 4.8 into 10 to the power minus 12 meter. Now we know 1 angstrom equal to 10 to the power minus 10 meter. So x0 will be 4.8 into 10 to the power minus 2 angstrom, or it is 0.048 angstrom. So the correct option will be option A, 0.048 angstrom. So I will calculate now this energy. Like here we are equating the energy equals to kT. So here the energy equals to half kx square. So using that value or that relation, we can calculate this h cross omega by 2 equals to half kx square. So from this relation, x square will be h by 2 pi into mu k root over. So if you put all the values, and we will find out that the value of amplitude of vibration is 0.048 angstrom. Then the next question, the question says, find the amplitude of vibration of HCl molecule. Find the amplitude of vibration for HCl molecule in the second excited vibrational level. The force constant K of the vibrating HCl molecule is given and the reduced mass is given, and consider the Planck's constant. So it is pretty much similar to the previous question. So I'll give you a few minutes to try this question and then we will discuss. So now let's solve this question. Now again we know half kx square is equals to the energy value. Now what is the energy level given? It is second excited vibration level, and EV is equals to V plus half s plus omega, or V equals to 2, E2 equals to 2 plus half h plus omega, which is 5 by 2 h plus omega. Now this 1 by 2 kx square is equals to 5 by 2 h plus omega. Now again 5 by 2 h cross omega is k by mu square root. So x square will be, or x0 square will be height h cross divided by mu k root over is 5 into 6.63 into 10 to the power minus 20 minus 34 divided by 2 pi into mu is 1.62 into 10 to the power minus 27 into 475. If you calculate, you will get 6 into 10 to the power minus 22 meter square. Now x will be root over of 6 into 10 to the power minus 22 meter square, which will be 2.45 into 10 to the power minus 11 meter square. So in order to convert it to Armstrong, it will be 0.245 Armstrong. So the correct option is option B, 0.245 Armstrong. So this question was again pretty much similar to the previous one. We simply equated the value of second excited energy level to half kx square, where x is the amplitude of vibration. Now, using the formula, the relation, we can calculate x is 0.245 Armstrong. I hope this is clear to all of you. Then let's discuss the next one. The problem says in the H2 molecule, the value of vibrational wave number omega is equals to 4340 centimeter inverse, and unharmonicity constant is omega E bar xc 120 centimeter inverse. Calculate the energy for vibrational quantum number V equals to 0, considering the Planck constant, and 4.2 joule is 1 calorie. 1 calorie is 4.2 joule. The options are option A 4.2 kilocalorie per mole, option B 6.1 kilocalorie per mole, option C 8.4 kilocalorie per mole, and option D 12.3 kilocalorie per mole. These are the four options. I'll give you a few minutes to try this question and then we will discuss. So now if we talk about this question, the question says the vibrational wave number is omega E and the unharmonicity constant is omega E and xc. So in general, if we talk about the unharmonic oscillator, then its energy is given as, like for harmonic oscillator it was only kx square term. If here there will be xq term, because this xq term corresponds to or contributes to the unharmonicity of the problem. Then EV is written as V plus half h cross omega minus V plus half square h cross omega xc. Now, in terms of wave number, we can write it as EV by HC, which will give V plus half omega E bar minus V plus half whole square omega E bar xc. So, this value omega E is given and omega E xc is given. Since all these are in wave number, so this quantity as the unit of wave number. Now we will use this formula to calculate. So this quantity is again called as GV is equals to V plus half omega E bar minus V plus half whole square omega E bar xc. So how we will then proceed, because since we have all the known quantities, we will simply put the values and get the answer. The vibrational quantum number V equal to 0 is given, omega E xc is given, and omega E bar is given. So if you put here it is GV, but here we want to calculate the energy, because in question the energy is given. So you can simply write is, since V equals to 0, it will be omega E bar by 2 into Hc minus omega E bar xc by 2 into Hc. So 6.626 into 10 to the power minus 34 into 3 into 10 to the power 8 by 2. We can take it common, and then it will be 4340 minus 120. So if you calculate, you will get 4.256 into 10 to the power minus 20 joule. But if you see the options are in kilocalorie per mole. So in order to convert it to calorie, we know 1 calorie is 4.2 joule. So we will divide it by 4.2. So it will be 4.256 into 10 to the power minus 20 divided by 4.2 calorie, or 1.013 into 10 to the power minus 20 calorie. But again, in order to energy per mole, it will be 1.013 into 10 to the power minus 23 divided by the Avogadro's number 6.023 into 10 to the power 23. So this 23 gets cancelled. Sorry, it is, so this will not be, it will be into kilocalorie per mole, means into it is 1.013 into 10 to the power minus 23 into 6.023 into 10 to the power 23. So it will give 6.1 kilocalorie per mole, because 1 mole contains 6.023 10 to the power 23 number of molecules. So it will be multiplied here. So the correct option will be option B, 6.1 kilocalorie per mole. So here this question was a bit different. Here unharmonicity was given in the question. So if you introduce the unharmonicity, the energy expression is given as V plus half H cross omega minus V plus half square H cross omega XC. So this omega E and omega E XC was given. This omega E and omega E XC was given. So if you put these values, so the energy will be omega E by 2 HC minus omega E XC by 2 HC, because V equals to 0. If you put all the values, you will get 6.1 kilocalorie per mole, and the correct option is option B. So continue our discussion to the next question. The question says the fundamental band for carbon monoxide molecule is centered at 2145 centimeter inverse and the fast overtone at 4260 centimeter inverse. So calculate the vibrational wave number and the unharmonicity constant. So now here the question is opposite to the previous one. Here the fundamental band for molecule is centered, or the position of the spectral line is given, but here we need to because here there are two positions, one is fundamental band, another is fast overtone band, and we need to calculate the vibrational wave number and the unharmonicity constant, which was given in the previous question. So the options, these are the four options. I'll give you a few minutes to try this question and then we will discuss. So now you see there are two lines, or the position of the two lines is given. The fundamental band of CO molecule is centered at 2145 centimeters and the fast overtone is again given. So if the transition occurs between the two levels, then what happens? What are the relations? So in the previous question we had discussed, G V is given as half omega E minus V plus half square omega E XC, omega E bar XC. So if the transition occurs from V equals to V prime to V equals to double prime, then G V, the transition from V double prime to V will be omega E V double prime plus half minus V double prime plus half square omega E xc minus, because it is one, it is corresponding to one level, the another level corresponding to V prime will be omega E V prime plus half minus V prime plus half square omega E xc. So if you calculate it, suppose one is V, another is V prime. So now here in the question, one is fundamental, another is first overtone. So the transition will be from V prime equal to 0 to, so here the given transition is from V prime equal to 0 to V double prime 1. So if you put these values, now the wave number G will be given as, you see here this, if you put the values, here will be omega E 1 by 2 omega E, and here again will be 3 by 2 omega E, and it will be 1 by 2 omega E. So it will be omega E so let's start put the value. So it is 3 by 2 omega E, sorry, 3 by 2 omega E minus 3 by 2 square omega E xc. So minus 9 by 4 omega E xc, then minus 1 by 2 omega E minus, this is 1 by 4. So this is 1 by 2, 1 by 4 omega E xc. So if you calculate, it will give you omega E bar 3 by 2 minus 1 by 2 minus omega E xc, omega E bar xc 9 by 4 minus 1 by 4. So it will be omega E bar minus 2 omega E bar xc. So this G V correspond to transition from double prime to single prime or 1 to 0 is omega E bar. If you take common, it will be 1 minus 2xc. So this value, now this 1 to 0 transition, the transition from 1 to 0 is fundamental one. Then transition from 2 to 0 is fast overtone. So again, if you calculate the transition from 2 to 0 or 0 to 2, then it will again be G transition from 2 to 0. Similarly, you can calculate, the value will be 2 omega E minus 6 omega E bar xc, 2 omega E. So it will be, take common 2 omega E bar, it will be 1 minus 3 xc. So if you equating the values, we will get this omega E bar into 1 minus 2 xc is equals to this 2145 centimeter inverse. In order to convert it to meter inverse, we will multiply it 10 to the power 2. Then 2 omega E 1 minus 3 xc is 4260 into 10 to the power 2 meter inverse. So if you solve it, then simply if you subtract equation, suppose this is equation 2 and this is equation 1. Now subtracting 1 from 2, we will get, see here it is uh, x omega e minus 2 x omega e, it is 2 omega e minus 4 x omega e. So it will be 1 minute. It will be 2 minus into 2, because then this omega e, 2 omega e, 2 omega e will be cancelling out. There will be 4 omega e xc and it is 6 omega xc. So 6 minus 4, it will be 2 omega e bar xc is equals to 3000. Then omega e bar xc will be equal to 1500 meter inverse. And again, if you put these values in the first equation, that is equation 1, that will give us 2145 into 10 to the power 2 is equal to omega e bar minus 2 into 1500. So omega e bar equals to 217,500 meter inverse. So this is omega e xc, this is omega e. So the correct option is, if you see, the correct option is option A. Omega e is 217,500 meter inverse and omega e x is 1500 meter inverse. So let me explain it to you once again. So basically, if you see the question, it was given the fundamental band for carbon monoxide molecule is centered at 2245 centimeter inverse and the fast overturn is at 4260 centimeter inverse, and we need to find out the two unknown quantities. So in order to find out the two unknown quantities, we need at least two equations. So in order to find the two equations, we will use these given values, and the fundamental band corresponds to transition from 0 to 1 and the fast overturn corresponds to transition from 0 to 2. So if you see, if we talk about the transition between the two levels, then since the energy expression for one level is given as this, so the transition between the two levels having values when v prime, v double prime and v prime will be omega e v double prime, then omega e v prime. So these are the two, this is for one level, this is for another level. So since for fast overturn, for fundamental transition, v prime is 0, v double prime is 1. So if you put the values and calculate, it will be omega e minus 2 omega e xc. So the transition from 1 to 0, or the fundamental transition, will give the wave number. The wave number corresponding to a transition of 0 to 1. The transition of from 0 level to 1 level is omega e 1 minus 2x. Similarly, if you calculate the second, the fast overturn, so second equation we will obtain it g equals to 2 omega e 1 minus 3x. So these are the two values of the wave numbers, and the two values of the wave numbers also given in the question. So it is 2145 into 10 to the power 2 meter inverse and 4260 into 10 to the power 2 meter inverse. So if you calculate or solve these two equations for these two unknown quantities omega e and xc, we can found omega is this one and omega e xc is 1500 meter inverse. So these are the correct answers of the unknown quantities, and the correct option will be option A. I hope this is clear to you now. Then we'll proceed to the last question of the day. The question says the fundamental band for DCl 35 is centered at 2011 centimeter inverse. The internuclear distance of DCl molecule is 1.288 angstrom. Calculate the wave number for the third line of each P and R branch of DCl 35 molecule. Reduced mass of DCl35 is 3.14 in 24 minus 27 kg, and Planck's constant is given also. Assume that there is no interaction between rotation and vibration, and also equal to small centrifugal dissolution constant. So this is pure. We will only talk about pure So we'll only talk about pure vibrational spectra. There is no rotational vibration spectra, so there is no interaction. So we'll simply use the formula, and then the fundamental band is given, and the internuclear distance is given. So and the reduced mass is given. So this is on pure rotational spectra. There is no vibrational spectra, so there is no interaction between rotational and vibrational that we have to assume, and small centrifugal distortion will be ignored. And the given options are, these are the given options. I'll give you a few minutes to try this question, then we will discuss. So this question is related to rotational vibrational spectra. So and in case of rotational vibrational spectra, there are three bands. The central band is called as Q branch, and then in the left side there is P branch, and in the right side there is R branch, and the spacing between them are 2B in each branch, and in between the two branches like P branch and R branch, the separation is 4B. So if you follow the lectures, then you can find out that the wave number for R branch is given as the wave number for R branch is given as omega 0 bar plus 2B j plus 1, and j starts from 0, 1, 2 like this. So here if you see, if you put j equal to 0, then omega 0 plus 2B, and then for P branch, P bar j is omega 0 bar minus 2bj, whatever j starts from 1, 2, 3 like this. So if you see, again, if you put j equal to 1, then it will be omega 0 minus 2b. So in the center there is omega 0, then omega 0 plus 2b corresponds to R branch, which is placed in the right, and P branch corresponds to the left side, which is omega 0 minus 2b. So there is a separation of b. Now in the question, it is given at the fundamental bands for DCL 35 is centered at 2011 centimeter inverse. So here the center is omega 0 bar. So From the question, omega 0 bar is 2011 centimeter inverse. Now we know the rotational constant is given by B, which is h by 8 pi square mu r square c. So if you remember the rotational spectrum session where we had solved numerous problems related to the rotational spectra. So the rotation constant B, the expression is given h by 8 pi square mu r square c, where mu r square is the moment of inertia. H, there is h cross by 2ic, because h cross square by 2I comes due to the agent value. Then if you put all the values, it is 6.63 into 10 to the power minus 34 divided by 8 into 3.142 square. Then mu, the reduced mass also given, it is 1 point, the reduced mass is 3.14 into 10 to the power minus 27 kg into the bond length is again given, it is 1.22 Armstrong. So it is 1.288 into 10 to the power minus 10 Armstrong r square. Then C is 3 into 10 to the power 8. So if you calculate it, it will give 537.3 meter inverse, that is 5.37 centimeter inverse. Now we got the value of B. Now if the value of B is given, what do we need to find? We need to find the third line of each P and R branch of DCl3 5 molecule. Now if you see third line means, I just mentioned, if this is the spectra, rotational vibration spectra, this is Q, which is omega E bar, then this side is R, this side is P. So there are different bands here and there are different bands here. So here it is omega E bar plus 2B, then plus 4B, plus 6B, like that. Then here it is minus 2B, minus 4B, minus 6B. So if you see, the question says find the wave number of third line of each P and R branch. So for P branch, the third line will be omega 0 minus 6B. For third line, P branch will be omega 0 bar minus 6B, which is equals to omega 0 we just calculated 2011 centimeter inverse. 2011 minus 6 into B is 5.37, 5.37, 5.37. So it will give us 2011 minus 6 into 5.37 is how much? 6 into 5.37, 32.22, 32.22. So it is 1978.8 centimeter inverse. So this is P. Similarly, corresponding to R, it is omega 0 plus 6B. So 2011 plus 6 into 5.37. This is 2043.2 centimeter inverse. So this is 2043.2 centimeter inverse. This is 1978.8 centimeter inverse. So the option is 1978 and 2043.2. So the correct option is option A. So now let's discuss this question once again. So the question was the fundamental band was centered at 2011 centimeter inverse. So the fundamental band we just discussed that these are the expressions for R branch and P branch. So fundamental branch means it is omega 0 only, the wave number. So omega 0 is given as 2011 centimeter inverse and the internuclear distance is given. So since the internuclear distance is given and the reduced mass is given, we can calculate the value of B, which is the rotational constant. So the value of B is 5.37 centimeter inverse. Now if you see the formula, in this formula, the R branch and P branch, each branch is separated by distance 2b. So for R branch, it will be separated from the central or the fundamental band by 2b. So it will be omega 0 plus 2b. Then for second member, it is plus 4b plus 6b like that. Similarly, it is negative for P band, which is omega 0 minus 2b minus 4b minus 6b like that. So we now obtain the value of B, and we have the value of omega 0 from the question. So if you have the two values, then the third member will correspond to omega E or omega 0 plus 6b and omega 0 minus 6b. So omega 0 plus 6b is 2043.2 centimeter inverse, and omega 0 minus 6b is 1978.8 centimeter inverse. So these are the, so this will the correct option. And the correct option, if you see, the correct option is option A. I hope this is clear to you. So with this, we come to the end of today's interaction session. In the next interaction session, I will discuss a few I will discuss a few more problems will be based on the week 12 of the interaction session. Till then, have a great time. That's it for today. We'll meet in the next session. That is on the 12th April 2024 from 7 to 9 p.m. And after that, there will be another extra session which I will take on next Tuesday, which will be a 1 hour session. And in that session, I will cover the whole thing that we have studied in this course. That is, it will be overall. It will be an overall revision for the course atomic and nuclear, atomic and molecular physics. So that's it for today. Thank you.